Okay, welcome to video 1110. Today we're going to be talking about quadratic application word problems, day 10 here. Let h of t equal negative 16t squared plus 64t plus 80. Represent the height of an object above the ground after t seconds. Determine the number of seconds it takes for the object to achieve its maximum height. So the key word here is maximum height, and that we need to go ahead and justify. So that means that I need to use math to back up my answer. Well, if we're talking about a maximum height, that's the turning point. So I need to go ahead and use my axis of symmetry formula, x equals negative b over 2a, to find the maximum height. So in order to do that, we need to write what a and b are. I don't really need c because it's not used for the axis of symmetry. And then I need to write down my formula and sub in what I have from my question. So negative b, negative 64 over 2 times negative 16. So that simplifies to become negative 64 divided by negative 32, which is a t value of 2, which is showing us the time, since this question was talking about the height and time in seconds. So the time occurs at a value of 2. So now I just need to reread my question to make sure that's what they were asking me for. Oh yes, it said determine the number of seconds that it will take for it to hit its maximum height. So I'm going to say that it takes 2 seconds. Okay, the next question says, state the time interval in seconds during which the height of the object decreases and explain your reasoning. Well, if I know that it achieves its maximum at 2 seconds and it's going to start at 0 seconds, I'm just going to plug this into y equals my equation and then check the table and write down my table of values. Okay, now I only wrote the t values of 2 and then up till it hits the ground because that's when it's decreasing. After it's gone up, hits its maximum height, and then starts coming down. So now I'm going to say, I found my answer by substituting the equation into y equals and looking at the table. I know the object will start decreasing after it hits the maximum height, which I found by solving for the axis of symmetry. Then it will stop after it reaches the ground, or a y value of 0. So that's how I determined that this would be the interval. Now, if you'll also notice, I put the less than symbols, not equal to, because at that top and bottom, it's not increasing or decreasing. So I can write it as 2 is less than t is less than 5. But we also have, which I think most of you prefer to write it, interval notation. So I could say it starts at 2 and it goes till 5, and neither one is included. That is an equivalent answer. So if it's a multiple choice, you may see it either way. But if it's a part 2, 3, 4 short response, you can just go ahead and write it in whichever way you are more comfortable with. Okay, so that's it for that question. After t seconds, a ball tossed in the air from the ground level reaches a height of h feet given by this function h of t equals 144t minus 16t squared. Then it says, what is the height of the ball after 3 seconds? Well, 3 seconds, that's a t value because t is measuring seconds. So in place of my t, I'm going to put the 3. And then you can just go ahead and put it in your calculator, and that'll tell you what the height is, h of 3, after 3 seconds. So give that a try and see if you get the same answer that I do. So when I sub that value, the 3, in place of t, then it's just a job for my calculator using parentheses to sub in, and you should get the height to be 288 feet. The next question says, what is the maximum height the ball will reach? Well, when we think about this, the maximum height, well, if it's asking for a maximum height, we can find that by identifying when it'll start going the other direction. So that's finding the axis of symmetry. So first I need to find the time when that maximum value occurs using the axis of symmetry formula, which is t equals negative b over 2a, and then sub in the a and b values, which I'll identify underneath the quadratic above. So I wrote down a equals negative 16 and b equals 144, but that might have been a little challenging because this wasn't in standard form. So off to the side I rewrote it so you can kind of see that a little better, that the a value is the one with the t squared and the b value is with the t. So remember that we need to look at it in standard form. Now that I know what a and b are, I can sub them into my axis of symmetry formula. So then I have negative 144 over 2 times negative 16. Remember, depending on your calculator, you can either put this in as a fraction, or you might need to clean up the top, clean up the bottom. Either way, you should get the same t value of
4.5. So now that just tells me when the maximum height happens. It's not the maximum height. Now I have to take that t value and plug it in place of t into my equation. So I'm finding h of 4.5. So when we plug in that 4.5 as the t value, we get out 324. So 324 feet is the maximum height. After how many seconds will the ball hit the ground before rebound? Well, that means after how many seconds hitting the ground, the key value point here is hitting the ground. We need to use that to find our value. If they're asking how many seconds, that means I don't know the t value. So I must know the height. Hitting the ground means the height is 0. So I'm going to put 0 in place of h of t. And for this one, I took my standard form equation so that it would be easier to solve. So I have the 0 equals negative 16 t squared plus 144 t. Now I have options. I can use completing the square, quadratic formula, or factoring. For this one, I'm going to use factoring because I can already see that these have a common factor. So to do that, I'm going to put this in a box and factor out the GCF. So off to the side, I just showed the negative 16t squared and the 144t in the box in case you still need to use this to factor out the GCF. I can see the greatest common factor here between the 16 and 144 is a 16, so I'm going to factor out this 16, and I'm going to also get rid of the negative because that'll make my a value positive. So taking out a negative 16 here. So with that negative 16t factored out, we need to fill in what would need to go here to make this negative 16t squared. So it would be a t up here, and then a negative 9 here when we divide the 144 by 16. So now I can rewrite it as the GCF times the t minus 9. Now always look to see if you can factor any further. I have this negative 16t and then just a t minus 9 since t is not a perfect square. This is not a difference of two perfect squares, so I'm all done factoring. Now that I have factored, I can put up my t-chart to show that if either one of these factors is 0, my product will be 0, so I'm just going to set each factor equal to 0. So on the left I have negative 16t equals 0, and on the right t minus 9 equals 0. So for this factor on the left, I'm going to divide by negative 16 both sides to get t by itself. So 0 divided by negative 16 is just going to be 0, so the t value is 0. On the right side I have t minus 9 equals 0, so add 9 to both sides. So then I have my two answers here, t equals 0 and t equals 9. So really my answer is the t value of 9 because when I talk about the t value of 0, that's just saying at the start. So before it's thrown or at the initial value, it's going to be on the ground. Then it will hit again after 9 seconds. So I circled both, but then just wrote off to the side. It's 9 seconds after the ball is thrown.
The next question says, a toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is given by the equation h of t equals negative 16t squared plus 64t, where t is the time in seconds. Determine the domain for this function in the given context, and then explain your reasoning. Okay, so when we talk about domain, we have to first identify what the domain is, knowing that domain are which type of values? X values. So I just wrote that underneath. Now, in this problem, though, there is no x. What is x being represented by? Well, if I look at my equation, it's the t. In goes the t, the number of seconds. So my domain, or x values, are really talking about t in this problem. So if we think about it, if we're looking for how much time can be passed, well, we know that time can't be negative, so it has to start at 0 time. What's the height at 0? So I'm going to write down a little table of values off to the side so that I keep track of what my t values are and what the h of t, or height, would be. So like I said, the first time would be 0 seconds. Then I can put my equation, the h of t from the question, I can put that in y equals so I can look at the table of values. So h of t equals the negative 16t squared plus 64t. Then second graph will show me a table of values. When I look at the table, I can see, okay, for 0 seconds, that means that the height is 0. Then at 1 second, the height is 48. And then I just keep looking. At 2 seconds, it's 64. At 3 seconds, it's 48 again. And then at 4 seconds, it's hit 0. Now, when I look at the height, I can't go into the ground. So that means the height can't be negative. Once it hits the ground, the 0 value, that rocket is going to have to just stop or rebound, something like that. So the time I can see in my table now starts at 0 and goes up to 4 seconds, including those two values. So I'm going to write down 0 is less than or equal to t is less than or equal to 4. We could also write this using the bracket around the 0, comma, 4 with a bracket saying that those are included. Now, I'm not done yet. The question said to explain. So it's very important to make sure that you do all parts of the question. So when I explain my reasoning, I'm going to say, determined the domain by finding a table of values that represent the situation. The time and height need to remain positive, so I started at 0 time and ended when the height reached 0 or the rocket hit the ground. Okay, let's look at the next question. The next question says, a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by this function, h of t equals negative 16t squared plus 64t plus 80. What is the height of the rocket after 1.5 seconds? So the first question is giving me a t value. Since I know that t is standing for the time, 1.5 is going to go in place of t in my equation. So I started by just writing my equation that was given to me in the problem, and since I knew this represented the height above the surface, the 1.5 needed to be the input, so in went 1.5 to find out what the height is. Once you have this with parentheses, you can just go to your calculator and put this all in so that the calculator can do order of operations for you. And then you should get the output of 140, and then I just put the label on there so I know what I'm talking about. It's 140 feet, so that tells me that the height is 140 feet after 1.5 seconds. The next question says, what is the maximum height reached by the rocket? Okay, so we're talking about a maximum height, that's an output, but I need to know where does that happen? So to find out where that maximum height happens, we're going to use the axis of symmetry formula, which is t equals negative b over 2a. Then I'm going to identify the a, b, and c value underneath my function. So up under the quadratic, you can see I wrote a is negative 16, b is 64, and c is 80. Now I'm ready to sub those values into my axis of symmetry formula. So then I can see negative 64 divided by 2 times negative 16. Depending on the calculator, you may need to put this all in your calculator as a fraction or simplify the numerator, simplify the denominator. Either way is fine. When you do that, you should get the answer that matches mine. T equals 2. But now that's not the answer to the question. That's just when the rocket will hit its maximum height. So to find out the maximum height, that's an output, the h of t, so I'm going to plug in the 2 in place of t in my equation. So I just showed in goes the 2 in place of t, and then it's a job for your calculator to do order of operations for you, and you should get the answer of 144 feet as the maximum height. The last part is asking us to find out the number of seconds after it is launched. The rocket will hit the lake. So the lake, that means that it's 0 feet above the lake. It'll hit the lake. So that means that my h of t is going to be 0. So let's just start by plugging in the h of t, replacing that with 0 equals. Okay, so now I just wrote in that 0 equals, and I have my equation. Now, since this is a quadratic, that tells me that I have 3 options really, either completing the square, using the quadratic formula, or factoring. I'm going to choose factoring for this one. So the first thing we look for whenever we factor is a GCF. When I look at the negative 16, 64, and the 80, there is a GCF, and I'm also going to divide out a negative. And the reason is because I don't want to need the negative a value. So if we divide it out with the term, then I can just have a positive t squared instead of a negative. So off to the side, you may or may not need this. I just put them all in a box to say, okay, I have a GCF that I'm going to factor out. What is the GCF between the 16, 64, and 80? Well, it's a negative 16, like I said, to make this a positive value. So I'm going to put negative 16 in front of the box and then fill in the top. So what times negative 16 is negative 16t squared? That means a t squared up in the top. And what times negative 16 is 64? That would be the negative 4 with a t, and then what times negative 16 is 80, that's a negative 5. So now I have a trinomial, so I'm just going to rewrite it over here with the 0 equals negative 16, then times t squared minus 4t minus 5. Now I can identify the a, b, and c value and use my x and my box to find out the factors. Okay, so I drew a, b, and c is 1, negative 4, and negative 5. So then I had my x, a times c, 1 times negative 5 is negative 5, b, negative 4. So I need two numbers that have a product of negative 5, but a sum of negative 4. So those would be negative 5 and 1. So I'm going to split the b term into negative 5t and 1t so that I can use factor by grouping. Then I can use my box to fill in those values from the factor by grouping into my box here. So t squared minus 5t. Okay, then I can pull out the GCF at the top here with the t squared and the negative 5t as a t, so that goes in this spot. And then I keep looking, so what times t would give me the t squared? That would be a t. What times t would give me the negative 5t? That would be a negative 5 here. And then what times the t would give me 1t? That'd be a positive 1 here. And then always check that last one. 1 times negative 5 is negative 5, so I'm confident. So now I can rewrite the t minus 5 and t plus 1 as my two factors for this factor by grouping. Okay, so then I'm not done yet. Now I need to solve for the number of seconds, because that was what the question asked me for, how many seconds. So now I can set up my t-chart, because if any of these factors are 0, the product will be 0. So I'm going to write each of these three equal to 0. Okay, so I just wrote 0 equals negative 16. Well, that can't be true. That's just not true, so that can't be an answer. T minus 5 equals 0. To get t by itself, I'm going to add 5 to both sides. Then I get my answer, t equals 5. And the next one, t plus 1, I'm going to subtract 1 from both sides, and I get t equals negative 1. Well, I have to reject this one too, and I'm going to write underneath it the reason, because time can't be negative, so I'm rejecting this negative. But it's not just because it was a negative, it's because the context of the question, it said the time value, time can't be negative. So my final answer is 5 seconds. Okay, so that's it for this video. Have a good night.